Okay, let's review. What does domain mean? X values. Okay, we're going to do domain a lot. You have to remember what domain is and how you're going to find that. What does range mean? Y values. Now let's talk about function. How do you know which one? How do you know what is a function? So let's say for 2 examples. Which one is not a function? Left one? Yes, correct. The one on the left is not a function. Do you guys know why? Yes.
Because you can't put in a x value, and it can't be a different y value.
Correct. So each x value can only have one y value, and in this graph you can see that x value has 3 y values. So that is not okay, and we do that by using the vertical line test. Basically, vertical line test says if you draw a vertical line, it cannot go through more than 1 point. This one went through 3 points, so it is not a function. Okay, so this is just review of Algebra 1, pretty much. Okay, now let's review. If f of x is x squared, what is f of 2? Everyone. 4. Okay, thank you. Is f of x a function? Yes, it is a function. X squared is a parabola, so it is a function, which is this one on the right. Okay, so now let's talk about this. We're going to basically find domain and range for all our graphs from this point on, and we're going to add on to all these things that we have to analyze, and eventually every graph I give you, you have to analyze the whole thing. First thing is we need to check domain. So whenever someone says find the domain, you're asking yourself 2 questions. First, can the x value make the denominator 0? Denominator. What happens if the denominator is 0? Oops. Okay, so is that okay? 1 over 0? No, we can never divide by 0, so that is not okay. If something makes the denominator 0, it is causing it to be undefined. Okay, so that's the first thing you check. Does it make the denominator 0? The second thing you check is inside a square root or a even root. So let's say radical sign. And that radical sign has to be even. So 2nd root, 4th root, 6th root. We don't care about cube root, 5th root, 7th root. Odd roots don't matter. The even roots are the ones that matter. Inside the root, it has to be greater than or equal, whoops, oh man, can't spell today, sorry, equal to 0. Remember, inside your radical, you have to be greater than or equal to 0. What happens if you're less than 0? What happens if it's a negative number? Yes, imaginary numbers. Imaginary numbers are not real, so we cannot have that happen. So inside the square roots has to be greater than or equal to 0, and then you check the denominator, make sure it's not 0. Okay? Let's look at an example. First one, f of x equals 3 over x. What is the domain? When someone says, what is the domain, they're asking you 2 questions. What can x not equal to? What can x not equal to? 0, because there's a denominator, right? The denominator cannot be 0, so x can't be 0. All right, next. Square root x plus 3. Is there a denominator? No, no denominator problem. But is there a square root? Okay, inside the square root has to be what? Greater than, equal to 0. Okay, so then x plus 3 greater than equal to 0. So what does x have to be? Greater than equal to negative 3. So if you could participate, it will help you remember better if you just kind of watch as things happen, you will not remember as much. So even if it's wrong answer, just say something, or even silently to yourself. That way you will think about it instead of just copy notes, because then you won't remember. Okay, number 3. This function. Is there a denominator problem? Yes. Is there a radical problem? Yes, there are 2 problems. Okay, so let's do the denominator first. What can x not equal to? Good, x can't be 5. Now, in the radical problem, what does x have to be? Greater than or equal to 0. So we have 2 problems, right? All right, now we are going to go back and fix all 3 answers, and we're going to write them all in interval notation. Okay, so first one. X is not equal to 0. Write down what you think it will look like if it's in interval notation. Okay, every number except 0. Okay, so I didn't really see a lot of correct answers. So let me show you how to do this. So kind of think about it as a number line. You have basically every single number except 0. So no 0. All right, how do you write this in interval notation? So starting from the leftmost, what is the leftmost number you can have? Negative infinity. And then what? 0. Stop at 0. Do I include 0? No, because we said no 0, right? So that is a parentheses. And then starting from what point? 0 again. And then to what? Infinity. So this is how you write. Basically, when you skip a number, you would change that number into 2 intervals, and you're connected by a u or the parentheses. All right, this one should be pretty easy. X greater than or equal to negative 3. Let's try Sherry. What'd you write? What'd you wrote? Minus 3 to infinity. And then what do we put on negative 3? Bracket? Yeah. All right, this last one is the trickiest one. Go ahead and try writing it down. So remember, you want to figure out what is your smallest number possible. Okay, so first, we cannot have 5, and it's greater than or equal to 0. So if you kind of think about it as a number line, you're basically saying starting at 0, go this way. But when you reach 5, skip. So your smallest number is 0. Not negative infinity. So if you started from negative infinity, you went too far. So we're going to start at 0. We're going to go to 5. We're going to skip 5. So that means we're going to put parentheses and then 5 to infinity. If you think about it as a number line, it's a little bit easier. Okay? All right. Let's have you guys try 1 and 2. Find the domain. Please don't get tricked. Remember, we're only looking for 2 things. Denominator, radicals that are even. Okay, so number 1, we cannot have negative 3. We cannot have 1. So that is negative infinity to negative 3. Negative 3 to 1. And then 1 to infinity. Number 2, there is no denominator and there is no radical. So that is all real numbers. Or negative infinity to infinity. Okay, please don't get tricked by things that are not denominator or not radicals. Next, we need to find range. This year, you're just going to use your calculator. Next year, you need to think about it. If you're taking calculus, you have to understand how the graph looks like, even if you don't have a calculator. But this year, that's okay. We just use the calculator. All right, we are going to figure out the range. So basically, same question. What can y not be? Or what is the possible numbers of y? So first, you're going to graph 2 over x with your calculator. So 2 over x, look at how that graph looks like. Okay, are you guys seeing this graph? Yes? Okay, so remember that this is how that graph should look like. Anything over x, the rational functions should look like that. If you don't see that, then you're zooming in too much or you're in the wrong parts of your graph. Okay, so next, you're going to ask yourself, what are all the possible numbers for y? Or what can y not equal to? Remember, y is the vertical part. So you're looking up and down, not left and right, up and down. So what are all the possible values of y? What do you guys think? my red graph exists everywhere on this y, which is up and down, except what number? Huh? 0. Yes. So my y, which is the red part, is, basically this left-hand part is going really close to 0, and then it's never going to touch it, and then this part begins above 0 and then goes up. So basically it's skipping over 0. That means we are going to write y is not equal to 0. Or what's another way of writing this in interval notation? Caleb? Oh, or Aaron?
I'm sorry.
Uh,
I saw the negative.
okay, Caleb.
Negative infinity 0.
Uh-huh.
And then 0.
Yes, so skipping over 0, this is what you write. So range is kind of difficult to see sometimes because you may not be used to looking in the y direction this way, but that's what you're doing. If this is very hard for you to do, what you can do is cover your graph, and then you just say, is there a graph? Oh yes, there's a graph, there's a graph, there's a graph, and then until this point, oh, no graph. And then you figure out what that point is, and then you continue up and say, oh, there's a graph, and basically write that as 2 intervals. Okay, let's do the next 2. I think you can do this. I think you can do this. Okay, graph both of them and figure out the range. Now on number 2, I just want to talk to you about how to actually put this in your calculator. Please be careful. Whenever you have a fraction, you have to make sure you put parentheses. This one, the numerator is just a monomial, so it doesn't really matter. But your denominator is a binomial. That means you need to, when you put division, you have to put parentheses. And then like that. If you don't, it's going to think that you're doing x squared over 1 plus x squared. You can see that is a totally different function. So please make sure you put parentheses. Got it? In the numerator, it's the same thing. If this somehow had an extra 1 or something, you have to put the whole thing in parentheses, or else your calculator is going to not do the right thing. So please be careful. Okay, find the range for 1 and 2. All right, let's look at it. So number 1, the graph looks like this. And again, if you cannot see this graph very well, block the whole graph and starting from the bottom and say, oh, does the graph exist here or not, and all the way up. So for example, this one, your graph looks like this. So then you say, is there a graph on the bottom? Yes. So that means you're going to start at negative infinity, all the way to a point here, and then there's no more graph. The question is, what is this point? What is that point? 6. Now, does it cross 6? Does it actually touch 6? Huh? Yes. So then that means we need to include 6. Okay, if it touches that number, then we have to include that number. So this is negative infinity to 6 included. Okay, number 2 is a little bit strange. You probably have never seen this kind of graph before. It's the same idea. So you just look at this graph starting from the bottom and say, is there a graph? No graph, no graph, no graph, no graph. Until this point, the graph starts. And the question is, what is this number? What do you guys get? 0, 0. Okay, so this is 0. Now, does it touch 0? Yes, you can trace on your graph, right? It's going to say 0, 0. So it does have a point at 0, so we are going to include 0. And then it's going to go up until here, and then there's no graph. The question is, what is that number? It stops. Huh? Did you guys find a number?
It should be 1.
It is 1. So basically, if you trace on this graph, your y value is going to say 0.999999, something like that. So it's trying to get to 1, which means there's a horizontal asymptote, so it's going to be 1, but not including 1. Okay, so this is range. This is kind of the more difficult parts, but you got to practice looking at your up and down or the vertical direction. Next, continuity. This is one of the most important things. Basically, it describes whether a graph has a break when we insert a x value, or in another word, can I draw this graph without lifting up my pencil? Can I draw this graph without lifting up my pencil? Can I draw this in one stroke? And do I have to draw it, stop, and then draw it again? If I can draw this graph with one stroke, that is continuous. If I have to take my pencil off and then draw it again, then that is not continuous. Okay, so we're gonna look at 5 types of continuity. So let me draw XY coordinate for all 5. Okay, what does it mean to be continuous? It means I can draw this graph with one stroke and I can finish this graph without lifting up my pencil. So, continuous at all x, something like this. So I drew that whole graph with one pen stroke without lifting it up. So that is continuous. Number 2. So once we start continuity, then I have to draw it twice. Removable discontinuity, if you remember from last year, means there's a hole. So I draw something, I have to take off my pencil to skip that hole, and then I continue. So that is 2 separate lines, that is discontinuous, and there is a break in between. Now we never draw it like that, we never put a break in between, we always put a hole. So you guys still remember this from last year, right? Holes. Okay, so removable means there is a hole. Number 3. Number 3 is another removable but different type. So you have this problem, you skip over, which means that there is a hole. But this hole is a little different. There is a point that fills in somewhere else on that same x value. So if you kind of think about it as like if you were walking, continuous means you just walk, you never have to skip anything. Removable means kind of like you have a manhole in front of you and then you have to go, jump over and then continue. And then removable with a point to replace is you walk and then you kind of step here and then come back to the original spot. Okay? Jump. Jump is something like this. You have a graph, you jump up to another place, and you continue. And one of them is going to be a hole. We don't know which one, but usually one of them is a hole. So basically you walk, and then all of a sudden this path stops. You have to start here and then continue. Okay, so that is also discontinuous, meaning it's disconnected. The last one is infinite. Infinite means that you have something like this. Goes up and down forever. Basically, if you recall, it's where we have asymptotes. All right, so what we're going to do is we are going to look at the graphs, or you're going to look at the graphs using your calculator, and then you're going to tell me if it's continuous or not. If it's not continuous, what kind of discontinuity does it have, and at what value? Now, I need to warn you, some of these are hard to tell whether it's discontinuous or not, so you always should check your domain restriction. Whatever makes the denominator undefined is always going to be a problem, whether you see it or not. Sometimes your graph may be deceiving. Please always ask yourself, what does my equation actually tell me? Should I see a discontinuity or not? Okay, so check your domain restriction. If it makes the domain undefined, there's going to be a problem on the graph. Okay, so let's do one at a time. Number 1, graph that. Again, please make sure you put parentheses around the numerator and the denominator before you put a division sign. and tell me if it's going to be continuous or not. If it's discontinuous, what kind of discontinuity do we have and at what x value? Okay, Junior, number 1. Is this continuous? No. Evan, what kind of discontinuity does it have? Infinite. And then Aaron, at what number? At x equals 2. Yes, you can tell because that's making the denominator 0. Okay? All right, let's try number 2. So graph that, or if you can already tell, you don't have to graph. All right, number 2. Mark, continuous or discontinuous? Good, it is continuous. There is no denominator. Oops. All right, number 3, let's have you try that. Okay, number 3. How many people think it's continuous? Raise your hand. How many people think it's discontinuous? Raise your hand. Oh, are people not raising their hand because they didn't finish graphing? Okay, 3 more seconds, finish graphing, and let's vote again. Okay, continuous, raise your hand. Discontinuous, raise your hand. Okay, discontinuous. Now, it might look continuous, but remember I said, don't get tricked. Look at is there a denominator problem? Yes, if there's a denominator problem, it will definitely be discontinuous, whether you see it or not. What happened is that there is a hole. And when there's a hole, you can't really see it. So remember from last year, if you kind of think there's a hole, you have to factor first. And you can see that this cancels. Whatever cancels makes the hole. So what happened is that you're actually seeing this graph. You're actually seeing this graph. And there's actually a hole here, but your calculator is so zoomed out, you cannot see it, so it looked continuous. But if you zoom in enough, it should show you a break. You have to zoom in a lot towards x equals 2. And you're going to see a hole. It's not actually going to draw out a circle. It's just going to be like a break, like that. But you need to be able to analyze this analytically without your calculator by just looking at it and say, that doesn't make any sense. This has a denominator problem. It definitely will be discontinuous, even if I don't see it. So this is removable. Discontinuity. And that is at x equals 2. Any questions so far? Yeah.
So if it cancels out, then that means it's going to be a hole?
Correct. Yeah, if it cancels out, it will be a hole. And then, so what we're going to do is tomorrow we're going to kind of put all that together. So when you're given a function, you have to analyze the domain, the range, the discontinuity, and then tomorrow we're going to add on. So then you're going to have a list of things you have to analyze every time a graph is given to you. No questions? Yes questions? If you have any questions at all, you got to ask soon because it will add up. And then this is going to be the basis for every single chapter because we're going to analyze a lot of graphs this way. Yes?
I just have a question on the graph, the second one, where
Yep.
it says,
Mm-hmm.
So I know that it's range 0, but what do you mean by 1? Like where it stops is at 1?
Yeah, so there's actually a horizontal asymptote at 1.
Ah, that's where it lands.
Yeah, it's trying to get to 1, but it's never getting to 1.